Hello everybody. Thank you for coming to this presentation. So today I'm going to talk about Liferay in a cloud-driven world. So this talk will not cover step-by-step configuration of Amazon Web Services, nor a Liferay cluster, or do some comparison of cloud providers. So this talk is about 3 concerns or drivers to move or not to the cloud. They are performance, scalability, and availability, cloud vs on-premise, pros and cons, and also a few tips and tricks for Amazon Web Services. Some of tricks are tied to Liferay portal, and some of tricks you will see they are actually more general tips for any application you want to actually deploy to Amazon Web Services. So, who is already using Liferay in cloud environment? Okay, and how many on Amazon Web Services? Oh, so we have few people. And who is considering moving to the cloud? Okay. So what drove the decision to move to the cloud? Okay, so there are actually few common reasons why people actually making decision to move to the cloud. So the first is avoid upfront capital investment. So I mean you are having portal, you want to build a new application, and actually you want to just to build a proof of concept and try it. The second one is you are startup, you want to build minimal viable product, and also you just want to try before going to some further investment. The second reason can be to better prepare to some catastrophic scenarios. One of famous cases actually is Netflix. He was down for 3 days because of some hard disk failure that caused a major database corruption. After that, actually, they moved all their operations to Amazon Web Services. And also, one of the reasons is to be able to handle demand fluctuations, also known as burst capacity. It means that when you have spikes in your to serving requests in some points of time during the day. So let's say you already have defined your functional requirements. So the next step is actually you need to define key non-functional requirements that your cloud provider of choice should be able to deliver to you. As I already mentioned, the first one is actually performance. So you want that your site is performing with the current setup the same way on the cloud as on-premise before even thinking about a growing actually load. So in that context, I'm going to talk a little bit about physical servers versus virtual servers, because when you are on the cloud, you're actually dealing with virtual servers, not physical servers. The second requirement is scalability, and I'm going to talk a little bit about how to actually automatically horizontally scale on Amazon. And the last one is availability, and I'm going to talk a little bit how to actually deploy your application to multiple data centers. So, how to define performance? How to measure performance? So, to be able to answer those questions, you need to make profiler of your applications. So, what are you? For what your portal using for? What features are you using from the portal? So when you answer those questions, so you will be able to actually define metrics that make sense, like page renderings, portlet renderings. You will be able to define what operations make sense, like logins, image uploads, or documents uploads and downloads, message boards, posts, etc. So when talking about performances, at the end of the day, it all goes back actually to system resources. CPU, memory, disk operations, and network. You know that many Java web applications, they are CPU bound. Liferay is not excuse. Memory availability also impacts how your garbage collector will behave, also your caching strategy. These operations also have impact when accessing database access and in Liferay case to search. Network performance, they have a really big impact when accessing enterprise services and some data repositories also. So when talking about the performance on the cloud, there are a few things you need to consider. So the first thing is that one virtual machine on the cloud is not the same as one physical machine. So you can see here from the Amazon website, this is one type of instance that Amazon is offering to you. You can see this red circles. So M3 instance type has 8 virtual CPU. So what does it mean? One virtual CPU is usually at most one CPU thread. So it means that actually the equivalent of one physical 8-core server would be at least 4 times large M3 instance. So this is important when you are actually going to choose which type of machines you want to run. So when talking about physical versus virtual servers, you need to put things into perspectives for easier cost calculation. So here you'll see some physical Dell server costing around $10,000 and the equivalent of the same machine, virtual machine on Amazon. For that price, you can run a machine for 3 years. And also one important notice here is that at the beginning, you will actually pay on less than half the price of the server, and the rest of the money you are actually paying monthly through the following 3 years. Also, important thing is that in those calculations, for both cases, the additional cost is not included, meaning electricity, stuff. So when actually making total calculation of your cost, for both cases, you actually need to be pretty careful when actually calculating those costs. Scalability. So what is scalability? Scalability is the ability of system to cope with growing load. Or you can say also scalability is ability of your resources to anticipate upcoming load. So when do actually capacity planning, you need to actually first ask yourself what is sufficient capacity for your actually application. How do you actually plan for scalability? So the emergence of those cloud actually providers simplified those actually planning by allowing you to on-demand using of resources and pay per use. So what does it mean? I want this server to run just for 3 hours and then shut down, and you'll just pay 3 hours of using actually that server. And also automation of the scaling process. So it means that you will see later on, Amazon allows you to actually start and shut down machines depending on some requirements. So we have actually two types of strategies. One is scale vertically or scale up, and the second one is scale horizontally or scale out. Scale vertically is when you actually are adding additional resources to single node, like putting a better CPU, more memory, etc. And scale horizontally is when you're actually adding additional nodes to your existing cluster of servers. So in this picture, you will see one typical architecture. It's not just tied to Amazon. This is typical architecture. You have a cluster of web servers. You have a cluster of application servers and running portal inside of them. They are actually in this orange box. You will see black boxes and something called auto-scaling group. That's actually the service, at least on Amazon. Every cloud provider has something similar that gives you ability to automatically scale your actually application environment. I'll explain a little bit later how actually that feature actually works. And you will see the second orange box. It means that when your group, for example, your load is growing, auto-scaling group can run additional set of your instances that will be added to existing ones. And actually, when your load starts to falling, those machines will be turned it off. And you will again just pay for the amount of hours you actually use those additional machines. So when talking about availability, you can often hear design for failure. But unfortunately, lots of applications deployed today to cloud are deployed without this point in mind. Why? They mostly because of technical awareness, how to actually design systems for high availability, or because of costs of operating such complex, actually, high availability setups in the cloud. We have few fault tolerance strategies based on types of failures. So we have actually serial failure, meaning in the same data center, and we have the second type, more complex, is actually when whole data center goes down. And for the first type of failure, we have classic strategy. It's clustering of your servers. And for the second one, it's called multi-data center deployments. Meaning you will actually have your application environment deployed across multiple data centers across the globe. And for that second one, you have actually three possible setups: hot cold, hot warm, and actually hot hot. Something. Okay, something went wrong with this slide. I'll just go quickly. So when actually clustering the Liferay portal on the Amazon, there are a few things you need to consider. First, you need to actually enable cluster link. You need to define cluster caching. The important thing is here when actually defining discovery and communication protocols that Amazon is not supporting multicasting, only unicasting. Also, you need to define proper file store system. Amazon actually has Amazon S3 distributed file store. So if you are going to store your documents, just okay. So in case of data center failure, what if actually whole center goes down? What are the actual main concerns in this disaster actually scenario? So how actually you will restore your system, especially database, file store, your application in case of portal, meaning you need to install again clean bundle, patches, plugins, properties. You can ask yourself, how automated is actually your deployment process? So as I already mentioned, there are actually three possible setups. In this case, the first one is cold. So what does it mean? It means that in your passive data center, you will just have hardware, and when active data center goes down, you are actually responsible for reinstall the whole system in that center. So it's the cheapest option, but also it's but takes the longest recovery time. The second one is warm or hot standby, meaning that your application is already running in the passive data center, but and waiting, but not serving requests. And usually you have one-way link going from active to passive data center, meaning that all necessary data will be synchronized between active and passive data center, like a database data and file store data. And the most complex one is actually hot setup, meaning that you are actually having your application environment deployed and active in multiple data centers, meaning that all your those data centers actually will serve requests. That setup actually gives you additional complexity like workload migration, data synchronization, network flow. And when you are actually I try to just put like a few capabilities that Amazon gives you and few pitfalls you will need to take care of if you are going this actually path. So first thing is Amazon actually supports inherent multi Amazon availability zone capabilities for most services. I didn't mention before each data center actually is divided between multiple availability zones that are actually connected with really fast links. What does it mean? It means that practices when you are having cluster of service in one data center that you spread them across multiple those zones. So if one of your zones goes down, so that your application is still alive and actually be able to serve requests. Also, there are things that are a little bit trickier, like most of services are actually regional or data center. They have scope just inside of data center, meaning when I want to that I cannot automatically have my virtual machine image automatically synchronize across multiple data centers. Then actually it's my responsibility to do it. Also, file store system. Also, you need to take responsibility if you want to also synchronize data across data centers. Also, regarding to serving requests, you need to use additional service to be able to route requests to all data centers. It's called Route 53. It offers you defining routing policies based on latency, geolocation, weight, and etc. So this is one typical architecture of application deployed across multiple data centers. So in each data centers, you have clusters of your web application, web servers, application servers, databases. You have link for necessary data synchronization, and also you have in front of all your data centers, you have this service Route 53 that will actually be actually routing requests based on geolocation, based on latency. So when actually comparing cloud with your own data center, in case of cloud, you can actually leverage appropriate regions or data center, meaning if you are in Europe, you have in Europe data center. If you are in US, you have in US. If you are in Asia, you have also data centers in Asia. You can scale in and out with load and just pay as much actually as you use your servers. But also cloud virtual machines that actually they can support less users per machine than actually real physical machines, and that's something you should be aware of. And also in this case you have only operational expenses. This is for accounting part of the whole system. In case of own data center, you need to build or rent data center. You need to actually procure sufficient hardware, but also you have greater flexibility in choosing that actually hardware. And also in this case, you have a capital and operational expenses. So final remarks. So don't discard actually hybrid approach, meaning you are mixing cloud and on-premise capacity. So you could, for example, build on-premise sufficient capacity to to handle 60 to 70% of your actually load, and for the rest, just use actually cloud for fault tolerance and burst capacity. So this is something that is becoming more and more actually relevant, especially I would say financial institutions or institutions that have really sensitive data. They simply don't want to, you know, put those data on some public cloud. They want to use that data in their own data center. Also, when choosing a cloud provider, look for key capabilities. They are auto-scaling, active monitoring, multiple availability zones, and also not less important is actually APIs those providers are offering you, so you can actually so you can have ability to automate the deployment actually process. The last slide is as I'm actually the member of Liferay Cloud Services project. This is some new project that will be offered to you, to clients, and actually it's deployed on Amazon Web Services. I will not talk about the project itself. You can hear more about the project in the next session from Juan Fernandez, our product manager. So I just want to emphasize a few things that we learned during building of that project. So all tips and tricks that I have mentioned are we are actually using, but there are also a few things that are, I think, worth to mention. The first thing is actually how you build your images that you will from which your instances will be started. So this is actually the manual, more or less manual process, especially when you're building Liferay images that will run Liferay, as Liferay is the most complex things. In this project, we actually have few types of clusters. Some are standalone applications, and also we have Liferay cluster of Liferay instances. And actually, it was the procedure, the process of building that image is the most complex actually one. There are a few tools you can use to build your images like Puppet, Chef, but in the end we decided to go just to using Amazon SDK, and there are few reasons. We wanted to have control over the whole process. So we actually built small Java application that we are running each time we want to deploy a new version of application. The second thing is I didn't mention before how actually automatic scaling is working on Amazon. There is also one service. It's called CloudWatch. So this is monitoring service that allows you to monitor various resources and also allows you to set alarms. And cloud scaling feature actually uses those alarms and accordingly actually starts up new machines or shuts down. So for example, I have alarm that I say if my CPU on servers is more than 80%, more than 5 minutes, then just go start new machine, or I don't know, 3 machines, 5 machines, depending of your configuration. And also the second alarm is if my CPU usage, average CPU usage is less than 20% for more than 5 minutes, just go down. So you have various possibility like network, as I said, CPU, and some metrics for other services like queues and stuff like that. So lots of actually a few hundreds actually of various metrics you can choose. Also, we were actually using one little project from Netflix. It's called Netflix Asgard. So this is actually a little web application that sits on top of Amazon SDK and helps us when we are deploying a new version of the system. So when we decide to upload the new system, we just build new images, create a new auto-scaling group, define those images in that auto-scaling groups, because we have a few types of groups, and we actually start those new machines. And if something goes wrong, actually this little tool is helping us to roll back to the old ones. So in theory, the client should never see that we are actually having problems. So far, we actually, as I said, the service is controlling beta. Our partners are testing it, and actually we are deploying during the day, working hours, so without actually client knowing that what we are actually doing. And so far it was so good, but we'll see when load will start to grow, we'll see actually how it's gonna be. So I would definitely prefer to look this little tool. So that's it. So if you have any questions, you can ask me, and it's gonna be a pleasure to answer it.
Thank you. So thank you for a nice presentation. So how can this be used with Liferay Enterprise Edition? How would that work with the license
Meaning on the cloud.
checks? Yeah.
So right now we have even for our project, we are actually also clients of Liferay Enterprise. We actually have license. This I think called enterprise license. It's normal production license, meaning that you are actually for each instance you are running, you need to pay like in running Liferay instances on premise. There is no difference for now actually. We don't have any special type of licenses for actually running on the cloud. They are the normal ones.
Regarding those licenses, we deployed on Amazon as well, Enterprise Edition, and then we run into the problem every time you start a new machine, it will get a new MAC address and new IP address. So every time you would have to ask for a new key.
Yes,
How did you solve that?
I think we have this type of enterprise license that actually uh, it's per instance use, but actually when changing IP addresses, MAC addresses, this license is still valid actually. Okay, there is actually our chief officer, operation officer, so you can talk with him, Michael Hahn, here, so you can maybe talk a little bit more about licenses.
Okay, thank you.
Someone else? I cannot see hands. Okay.
Okay, thank you very much. Application.